In this lesson, we will learn how to factor out a common monomial factor from a polynomial, where the common monomial factor involves only variables. Let's consider this first example. xy plus xz. In this case, we need to find a common monomial factor in both of the monomials that make up this polynomial. To find that common monomial factor, we should consider each variable that appears in the polynomial. In this case, there's an x, a y, and a z. The only way that we can factor out a monomial is if it's a common factor of all of the monomials in the polynomial. For instance, we see in this monomial an x, and in this other monomial we also have an x. Contrast that with the y. Y is only found in the first monomial. We can't find any y's in the second monomial. Similarly, the z is only in the second monomial, so it's not common to all the monomials within the polynomial. Since there's an x in both monomials, that is the common factor. To factor it out, we write whatever common factors that there are, in this case just x, in front. Then, we need to set up a distributive property problem. Remember that factoring is very much like undoing the distributive property. We're going to start with a polynomial expression and rewrite it without changing its value so that it will be the common monomial factor times a polynomial that would get us back to the original polynomial. So at this point the question becomes, what can I multiply x by to get xy plus xz? Since the original polynomial has two terms, the new polynomial should have two terms inside the parentheses. In other words, when I distribute this x, I'll have to distribute it to two different terms. When I'm trying to figure out what the first term should be, the question I'm trying to answer is, what do I multiply x by to get xy? The answer there would be y. When I distribute, x times y will give me xy. Now I need the second monomial, so I'll put a plus sign. And now I need to figure out what I multiply x by to get xz. Xz simply means x times z, so the answer here is I multiply x by z to get xz. Anytime you've factored, you should always check your work by distributing. In this case, if I distribute my factored form, I'll have to multiply x by y, and x times y is xy, and I'll have to multiply x by z. X times z is xz. I'll know that I've done my work correctly if, after I distribute my factored form, I get the exact same thing that I started with, and in this case, I did. Let's consider a second example. X cubed plus x squared y. In this case, we can notice that in both of our monomials, I have an x. The y appears in only one of the monomials, so I won't be able to factor out any y's. The difference here, however, is that the x has exponents in this case. What I want to do is figure out how many x's I can factor out, how many factors of x I can possibly factor out. Now, you don't usually want to write this part down. You want this all to happen in your head, but let's go ahead and write it down so we can see what we're going to be talking about here. Remember that x cubed means x times x times x, and x squared means x times x. So I could rewrite this expression as x cubed, or x times x times x, plus x squared times y, or x times x times y. What I want to do is factor out as many common factors from the monomials as I can. So in the first monomial I can find an x, and in the second monomial I can find an x. But there's also another pair of x's that I can match up. There's nothing to match this x with and nothing to match that y with. So what I'm noticing is that since the smallest exponent is a 2, that means that the most I could possibly factor out from both monomials would be 2x's, or x squared. So let's do that. The number that you're factoring out, the expression I should say, that you're factoring out goes in front to be multiplied by a polynomial that will result in arriving at the original polynomial after you distribute. Now the question becomes, what do you multiply x squared by to get x cubed? And what do you multiply x squared by to get x squared times y? X squared times what would give me x cubed? To answer that question, I should use the rule of exponents that states, when multiplying like bases, add the exponents. In order to make this base of x have an exponent of 3 instead of 2, I need to have another base of x so that I can multiply like bases. And I need to be able to add to the exponent. What do I add to 2 to get 3? The correct answer there would be 1. This should be x to the first power. Anytime we're going to use x to the first power, we don't have to give it the exponent of 1. We can just leave it as x. X squared times x will give me x cubed. To find out what monomial goes here, I need to multiply x squared by something to get x squared times y. That will need to be a y, because x squared times y will give me x squared y. Now if we check this, again using the distributive property, here's what we should get. X squared times x. I'm multiplying like bases. You can write this literally, x squared times x. And this might shed a little more light on what I was talking about with when multiplying like bases add the exponents. We were kind of working backwards from that rule. Because notice what's happening now that we're distributing. Now we're multiplying like bases. And when multiplying like bases, add the exponents. Anytime a variable does not have an exponent, you can give it an exponent of 1. Add the exponents. 2 plus 1 is 3. So this leaves me with x cubed. Then multiply x squared times y. That'll give you x squared y. And since when we're finished, we have the same thing that we had when we started with, we know that this is the correct factored form. Let's consider one final example. A cubed b squared plus a squared b plus a to the 5th b to the 4th. In this case, we're working with a trinomial, so the common monomial that we'll factor out will have to have factors in common with all 3 terms. Let's consider the variables. There's an a in the first term, an a in the second term, and an a in the third term. So we will be able to factor out at least one factor of a. Similarly, there are b's in all 3 terms. So we'll be able to factor out at least one factor of a and at least one factor of b. Now, we cannot factor out more factors than a monomial has. So the first monomial has only 3 factors of a that could possibly be factored out. The second monomial has fewer factors of a, only 2 factors of a that I could factor out, while the third monomial has 5 factors of a. I can't take more factors than the smallest number of factors in a monomial has to give. In this case, the second monomial just has 2 factors of a. That's the smallest number of factors. So a squared is the most I could factor out from each of those a's. Looking at the b's, essentially what I'm looking for is the smallest exponent on the b's. This one has an exponent of 2. This one has an exponent of 1. Anytime there's no exponent, you can write in an exponent of 1. And this one has an exponent of 4. The smallest exponent is 1, so I can factor out one factor of b. Now, just like always, I need to put a polynomial in the parentheses that I'll distribute a squared b to. Since our original polynomial is a trinomial, it has 3 terms, I'll need 3 terms inside the parentheses. So I'll distribute a squared b to a first term, a second term, and a third term in order to end up with this original result. Now I need to figure out what I multiply a squared b by to get a cubed b squared. I'm going to take it factor by factor, variable by variable. What do I multiply a squared by to get a cubed? This is a times a, and this is a times a times a. I need one more factor of a, so I'll multiply by just a to the first, or a. B times b will give me b squared. Add that to a squared b times what gives me a squared b. I'm not changing anything, so in order to multiply, I should multiply by 1 to not change the value. A squared b times 1 will give me a squared b. Plus, what do I multiply a squared b by to get a to the 5th, b to the 4th? I need 3 more factors of a to go from a squared to a to the 5th. So I need to multiply by a cubed. And I need 3 more factors of b. So this is going to be b cubed. Anytime you've finished factoring, you should always check by distributing. A squared b times ab is what the first term will give us. I'll add that to a squared b times 1. And I'll add that to a squared b times a cubed b cubed. Here we can multiply these term by term. The first term gives us a squared times b times a times b. I should multiply the like bases, and when multiplying like bases, add the exponents. A squared times a, this is actually a to the first. Anytime there's no exponent, you can write an exponent of 1. A squared times a to the first, I'll add the exponents to get a cubed. B times b, again I can put exponents up here. That'll be b squared. Plus, this is a squared times b times 1, and anything times 1 is itself, so this value will not change. That'll remain a squared b. I will add that to a squared times b times a cubed times b cubed. Again, I'll multiply the like bases and add the exponents. A squared times a cubed, adding the exponents, gives me a to the 5th. This b, I can write an exponent of 1. 1 plus 3 is 4, so I'll get b to the 4th. I should check to make sure that what I ended up with after I distributed is the same thing that I started with before I factored. And indeed, in this case, it is.